Okay, the next problem. Rain gutter is to be made of aluminum sheets that are 20 inches wide, as shown in the figure. Okay, so this figure below is this one right here. The edges are turned up to form right angles. What depth will provide the maximum cross-sectional area allowing the most water to flow? So let me give you a visual of what's going on here. We have a piece of paper like this, and what you're doing is you're actually folding the edges up to where it looks kind of like that. So it's a flat piece, and we're taking each end and we're doing this. We're folding the ends up. So because of that reason, when we fold them up, it's going to form this kind of trough right here, and this is basically going to be where water is going to be flowing through after we bend the corners up. So here's a flat piece, and what I have here is these dotted lines are representing the fold lines on that. We're saying that that sheet's 20 inches across. It doesn't matter how long it is. We're basically just concerned about the width. So we're going to take and we're going to bend up the corners, and by doing that, it's going to create this. Now, if I were to draw a dotted line across here, what that would do is that would create a box. So what the question is asking for is how low does this have to be, or what's the dimensions of this side to where it'll allow the most water to flow through. So again, I'm using my material most effectively. I have a piece here that's 20 inches wide, but I need to know what dimension to make this to where it'll allow the most water to go through. Okay, so the part that I'm going to fold up, I'm actually going to call each of these X. So X is the amount that I'm folding up. So that means these are both the X right here. That's how high it is. So eventually I'm going to solve for X, and that's going to give me my answer. Now I need to figure out how wide this is based on the picture that we have here. So this is 20 inches all the way across, and I have an X and I have an X here. So I want to find out the part that's in between there. The part that's in between, it's going to be 20 minus 2x. The reason why is because I got 20 all the way across, remove this x, remove that x, it leaves you the space in between, and that's going to be 20 minus 2x. So that means that that's the part that's going to be down below here. That's 20 minus 2x. So I have the two dimensions, and I want to find an area. So to find the area, I'm going to multiply these together. I have x times 20 minus 2x. That's going to be the equation that's used. That would be the one that has one variable only. And if I multiply it out, that's going to give me my quadratic equation that I need to use when I use the negative b over 2a vertex formula. With it in this form, remember the a is in front of the x squared and the b is in front of the x. So be careful when you put it into the formula. So I have negative b, I have negative 20 over 2 times negative 2. And so when I divide that, I'm going to get 5 as the answer. So that would be 5 inches. So again, negatives cancel out and I get 5 as a result. So that tells me that in order to make this allow the most water through, I want to make that a 5. So the question is, do I have to do anything else here? Well, let's read the question. It says, what depth will provide the maximum cross-sectional area allowing the most water to flow? So it's only asking us for the depth. It's not asking us for the area. If they did want the area, then we could put 5 back into this expression here, and that would tell us what the maximum cross-sectional area would be. But in this case, it's just only asking for the depth. So your answer is just going to be x equals 5.